This video is brought to you by NEMA Arrestor Section 8LA and is about the new energy handling tests that will be part of the next IEEE standard C6211. There are many parameters of arrestors, but its energy ratings are near the top in importance. Since arrestors are installed on power systems to clamp both lightning surges and switching surges, they can dissipate fairly high levels of energy in the course of this activity. Since there are numerous arrestor types and functions, there are several different energy ratings to be considered. The energy handling ratings in IEEE C6211 were last changed in the 2012 edition for station class arrestors only. In the upcoming 2019 edition, the energy ratings will be modified again, but this time for both station and distribution class arrestors. This video gives a preview of the changes and the rationale behind these changes. Distribution arrestors are most often located near equipment, such as transformers, reclosers, etc., that cannot handle the stress from a lightning surge without failure. The purpose of the arrestor is to limit the voltage across the insulation of the equipment to avoid failure. It accomplishes this act by channeling the charge from the stroke around the protected equipment to earth with as little energy dissipation as possible in the arrestor. And when the lightning current discharges through the arrestor, some of the charge is converted instantaneously into heat energy. This is due to a small resistance the arrestor has during its turn-on stage. In 2019, a new operating test will be introduced. The purpose of this test is to confirm that the arrestor design will remain stable and operational after significant charge transfer. The test is completed in such a way to simulate the worst possible conditions on the system. Since this is a test about thermal stability, it is carried out on a sample that has been modified to have the exact thermal cooling characteristics as the longest arrestor in the design family. It assumes that the longest rating has the worst case thermal cooldown parameters since there are so many hot disks in series. The test consists of 4 sections carried out one after the other for each arrestor design. The rationale for each section of the test are as follows. In Part 1, 2 tests are run that verify the protection level and arrestor rating. A 10 kA lightning surge is forced through the arrestor and the discharge voltage across it is measured. It will be used for comparison at the end of the test. The VREF test ensures that the MCOV level used during Part 3 of this test is correct. Part 2 is a high current impulse that is applied to represent a severe field experience that may change the arrestor parameters over its lifetime. Arrestor research has indicated that high current surges are the only type of surges that can age or change characteristics of MOV type arrestors. Part 3 of this test verifies that the arrestor will remain stable after it is subjected to maximum design charge transfer. The arrestor is heated prior to the test to represent the hottest environment it could ever experience. It is then impulsed with its rated charge transfer capability, then energized at AC. If after 30 minutes the arrestor has cooled down, it means that the arrestor is thermally stable and the arrestor has passed its significant stress. Part 4 is a retest of the discharge voltage, and its value is compared to the value at the start of the test. This revised operating duty test has been adopted to better represent field conditions and is believed to test the arrestor performance better than the previous duty cycle test. Starting in 2012, the station class arrestor was required to pass a single impulse withstand test. Starting in 2019, distribution class arrestors will be required to pass a similar test. For distribution arrestors, this test replaces the low current long duration test that was never quite relevant to this type of MOV arrestor. The purpose of this single impulse test is to demonstrate the arrestor's ability to repeatedly withstand a charge transfer through the arrestor at the level to which it is certified. It should be noted that this test is not a thermal evaluation of the arrestor, but strictly a single impulse surge withstand capability repeated 20 times. For that reason, the test is carried out on MOV discs instead of a complete arrestor. Let me explain the relevant parts of this new test. The first part of the overall test consists of two initial tests to verify the initial characteristics. This is done with a 10 kA surge to quantify the protective characteristic, and then the turn-on voltage of the disc is checked with VREF. Part 2 is a severe series of 20 impulses, 2 at a time, at the rated charge transfer capability of the disc plus 10%. It is understood that any failure of a disc is somewhat of a statistical event, and it is accepted that this is not truly a statistical test, but it is understood that 20 impulses is more severe and more quantifiable than 1 or 2 impulses, as done in many other tests. Part 3 is the verification section of this test. If the parameters have not changed more than specified in the test, then any arrestor produced using these discs can be rated with this charge transfer rating QRS. If only 1 of or 2 of the 20 discs fail, the arrestor can be rated at 90% of the charge transfer used in the test. In the 2019 edition, only a few small changes will be made to the station class energy handling tests. It may be hard to believe, but for arrestors located in substations, lightning is not the major surge source. Switching activity of high voltage breakers are the root cause of severe surges for station class arrestors. Every time a circuit breaker operates, it creates a switching surge at some level. If the breaker contacts close to energize a system when the voltage is at peak value, a switching surge of up to 3 times the normal voltage can appear on the line. Since most station class arrestors begin to protect the system at levels as low as 20 to 30% above the operating voltage, when a switching surge appears on the line, the arrestor turns on immediately. When turned on, they clamp the voltage and generate heat internally due to the resistance of the arrestor. It should be noted that switching surges only become a challenge to arrestors on systems of 245 kV and higher. The purpose of this energy handling test of station class arrestors is to determine and verify the maximum energy dissipation capability of the arrestor during a switching surge. From this test, the arrestor switching surge energy rating is assigned. Part 1 of this test is to establish the pre-test protective level and AC ratings of the arrestor. The 8x20 impulse establishes the protective level, and the VREF is used to establish the MCOV of the sample. In Part 2, the two 65 kA surges represent the worst case possible electrical aging this arrestor could experience over its lifetime. This level is lower than distribution arrestors, since station arrestors seldom see high lightning currents in a substation. The third part of the test is to inject significant switching surge energy into the sample and then check for stability after the event. The arrestor is heated to 60 degrees C to replicate the worst possible environmental situation in the field. The arrestor is then impulsed with 2 rectangular-shaped surges that sum to the desired energy rating of the arrestor. After the energy input, the arrestor is subjected to a 10-second overvoltage that represents a typical 10-second TOV. It is followed by the application of MCOV for 30 minutes. If the arrestor cools down and becomes electrically stable over this time period, it is considered to have passed this part of the test. The fourth part of the test is a final impulse to verify that the arrestor was not damaged during the surge, and to verify that the protective characteristics had not changed by more than the specified amount. Again, it should be noted that this test is ran on thermally and voltage prorated sections The improvements to the energy handling test in the 2019 edition of IEEE C6211 will bring a more realistic and a more practical set of tests to assess modern MOV arrestors. This video has been brought to you by the Surge Arrestor Section 8LA of the National Electrical Manufacturers Association, and they encourage you to keep on learning.